International Union of Pure and Applied Chemistry. It is an international federation of national adhering organizations that represents chemists in individual countries. UPAC naming rules are very important because without them, we will not know how to draw its structure or distinguish them from the different types of hydrocarbons. Methane is the most important and most common hydrocarbons, and it's also the smallest one. Followed by it is ethane, ethene, ethine, propane, and propene.
Hydrocarbon is an organic compound that consists only of carbon and hydrogen, and there are several types of hydrocarbons like alkanes, alkenes, alkynes, cycloalkanes, and aromatics.
Hydrocarbons that contain only single bonds. The steps to name the alkanes based on the UPAC are: write the alkane name of the longest chain of carbon atoms, then number the carbon atoms starting from the end and near a substituent, and finally give the location and name of each substituent, in alphabetical order, as a prefix to the name of the main chain.
To draw the structural formula for an alkane, there are only 3 steps. The first step is to draw the main chain of carbon atoms. The second step is number the chain and place the substituents on the carbons indicated by the numbers. And the third step is add the correct numbers of hydrogen atoms to give 4 bonds to each C atom.
These have a general formula CnH2n. They have fewer hydrogen atoms than the alkanes. The extra balance left over occurs as double bonds between a pair of carbon atoms. Double bonds are more reactive than single bonds, making the alkene chemical more reactive. The UPAC rules for alkene and cycloalkene nomenclature are: first, the "-ine" suffix ending indicates an alkene or cycloalkene. The longest chain chosen for the root name must include both carbon atoms of the double bond. The root chain may be numbered from the end nearest a double bond carbon atom. If the double bond is in the center of the chain, the nearest substituent rule is used to determine the end where numbering starts. Finally, the smaller of the 2 numbers designated to the carbon atoms of the double bond is used as a double bond locator. If more than one bond of double bonds is present, the compound is named as a DN, 3N, or equivalent prefix indicating the number of double bonds. Finally, and each double bond is assigned a locator number.
The alkynes are unsaturated hydrocarbons that contains 1 or more triple bonds between carbon atoms in a chain. Triple bonds involve the sharing of 3 pairs of electrons. Its general formula is CnH2n minus 2. The simplest and most commonly used alkyne is ethine, C2H2. The nomenclature of alkynes is identical to that of alkanes. The only exception is the ending "-ine". The aromatics are organic compounds that contain benzene ring as part of their structures. They were named because of their strong aroma, but now they are defined as anything that has a benzene ring. They are six-sided structure with single and double mobile bonds, C6H6. Naming aromatics. Substituted benzene compounds are named the same way as cyclic alkanes. Substituted benzene rings are numbered in the way that gives the lowest possible numbers for the substituents. Another way naming the benzene compounds are using the terms ortho, meta, and para. Ortho means 1 and 2, meta 1 and 3, and para 1 and 4. In order to draw the structural formula for the alkanes, we first need to draw the main chain of carbons given by the name, then locate the double bond in the chain given by the number in the formula. Next, place any alkyl groups or substituents on carbon atoms. Finally, add the correct number of hydrogen atoms to give 4 bonds to each atom. In order to draw the structural formula for alkanes, first we need to draw the main chain of carbons given by the name. Then, locate the triple bond in the chain given by the number in the formula. Place any alkyl groups or substituents on carbon atoms. Finally, add the correct number of hydrogen atoms to give 4 bonds to each carbon atom.